So today we're going to go over kind of an intro and overview of our company, who we are. We'll jump into a desktop metal demonstration, which consists of a new Pure Sinter furnace and three separate desktop metal 3D printers. Then we'll kind of just wrap it up and tell you about what we've talked about before or earlier in the presentation, where you can find these materials, and then we'll open it up for some questions. So as I mentioned, we have Axel. He's our additive manufacturing lead at CCCS. We have Tiana, who's the regional technical manager for Desktop Metal, and myself with CCCS as the strategic business manager. This is scheduled for 1 hour. We do have Q&A open, so if you have any questions, feel free to put them into the chat. Please keep them appropriate, and we will do our best to answer all the questions by the time the presentation is over. We may answer them as we're going along, whether that's in text or whoever's presenting can take that answer, or we'll keep them to the end. Depends on the question. And then as a follow-up, if you're interested in Desktop Metal, please get a hold of us. We will put in all of our contact information at the end, and we are recording this, so we will make that available on our YouTube page as quickly as we can. Most of you came in already muted, and your camera's off, so I just request that you leave them that way. So who are we? Since 1993, we've served the Southern California and surrounding areas with manufacturing products for additive, subtractive, and inspection. Now that's hardware and software solutions. So for additive, we sell desktop metal and robos. For subtractive, we have Mastercam as our flagship, with Cam Assist that works in Mastercam, Simco as well that does some probing, Mold Plus, and Vericut for simulation. On the inspection side, we carry Verisurf as well, which is also for R&D, reverse engineering, inspection. So we are local. We are experienced in the local landscape and just in manufacturing in general. Our staff is very dedicated. We have offices in Anaheim, Newbury Park, and San Diego. In all three of those offices, we offer on-site training, but we also have online training options, depending on, if you can get away from the office or not, or if you just prefer to learn in an online fashion. So to sum that up, we do know the local community, and it truly is our goal to make your business successful. That is what we consider our success as well. So we've been putting out this closed loop manufacturing concept over the past 6 or 8 months. It's really the process of going art to part through the entire cycle with the products that we represent. So we did it in a real world tested way to kind of prove out our concept with that putter. So we took an existing putter and we reverse engineered it and scanned it in with Verisurf. Then we 3D printed that putter with desktop metal and stainless. And we actually, for some work holding, used Robos with Carbon PA Pro to create the work holding because it was a very unique piece of work holding as opposed to traditional machining. Then, of course, we had to program it for the finishing passes in the face of the putter and the engraving. We did that with Mastercam and Cam Assist. We wanted to make sure that it was going to run as intended on the CNC machine, so we brought in Vericut to do that. And then before, during, and after the machining process, we used on-machine probing with Simco. And then, of course, at the end, we inspected it with Verisurf to make sure that it came out exactly as we intended. So we do offer all of these products. If you're interested, please reach out to us. And we did test the putter in a real world scenario. Came out really well, did not help my golf game. So we're going to jump into desktop metal with the Pure Sinter furnace and Live Center software with Tiana. So I will let you take it away and just let me know when you need me to advance the slide.
Awesome. Thank you. So yeah, we're gonna start with Pure Sinter, which is our new furnace that we've recently released. Basically, with this furnace, the challenge that we were trying to solve is that traditional vacuum furnaces haven't really seen a lot of big innovation in the way they're designed, the way they work, all of that. So we designed our Pure Sinter furnace to deliver a high purity furnace with an airtight hot-walled vacuum retort in a clean processing environment while keeping the costs of the furnace relatively low compared to a lot of the industrial sized solutions. Next slide. So this is how we came to get to the Pure Sinter furnace. So it is an affordable state-of-the-art furnace with an all-new design. With this furnace, it is compatible with a few different gas types, including argon, nitrogen, forming gas, and air, which are the main gases that we use to sinter our parts through all of our processes. We are able to reach a max temperature of 1420 degrees Celsius with a temperature uniformity of plus or minus 5 degrees Celsius. We do have a cooling rate from 1420 C, our max temperature, to opening in about a little under 4 hours. And that is because we do have about 17 cooling fans that help us do a rapid cooling cycle. Our maximum power draw is going to be under 13 kilowatts, and our steady state holding power is about 7 kilowatts as well. Next slide. So with the Pure Sinter furnace, it is designed with a vertical furnace design. So our thermal hood is going to lift up with the use of control buttons through the UI. There's no doors or anything that you have to worry about closing the seals or anything like that. It's just the vertical lift hood. When it is lifted, you are able to see very clearly into the retort environment, and you have very easy access to all the shelving from both the front or the back of the furnace. It is also equipped with a modern touchscreen UI, which is preloaded with our software that has the program parameters of many of our sintering cycles, as well as the opportunity to program your own cycles as well if you're looking to develop new materials. And it's very easy to get started with those sintering cycles. Next slide. Like I mentioned before, we do have active rapid
Oh,
cooling. Ooh,
sorry about that.
no worries. We do have the rapid cooling. We have a total of 17 fans as well as a pop-out ceiling vent to help with that cooling. So we did opt against expensive water-cooled walls, which is what helps us keep our costs down on this type of furnace. But with those fans, we are able to still get a rapid cooling cycle of under 4 hours. We do also pair the Pure Sinter with our sintering software called Live Sinter, which is a simulation software that I'll get into a little bit more in some future slides. But it's a software that allows us to simulate your parts through the entire process of additive and sintering. And it's going to predict how those parts are going to react within those sintering cycles. So it helps us get to our final iteration of the part a lot faster. Next slide. One other great benefit of the Pure Sinter furnace is it is very highly efficient with pretty low operating costs. We do have the airtight seal and the cooling system, so it does offer a dramatic improvement over some of the other furnaces that have large costs in the amount of gas they're using, the power they're using, stuff like that. So this furnace is a 200 to 220 volt system, and it's very efficient in the way that it runs. Next slide. One other thing that is great about our solutions is Desktop Metal is one of the only manufacturers to offer a portfolio of metal 3D printing solutions that allow you to scale your entire processes from development to serial production. So the Pure Sinter furnace is designed to be compatible with across all of our printing technologies, and including the Studio System, which is our bound metal deposition system, which I believe Axel will be talking a little bit more in the next few slides, as well as all of our binder jetting systems across all the different scales of production. These are some of the specifications of the Pure Sinter furnace. I'm not going to go through all the details here, but you can also find this information on our website as well. But we do have a pretty decent work envelope. Our retort volume is about 15.8 liters. And this is how we sinter all of our parts across all the platforms. One great thing about the Pure Sinter is the clean and modern shelving that we have. So all these shelves slide in and out. You can choose to put the shelf in, or if you have taller parts, you can leave out certain shelves so that you can fit your taller parts into the furnace. These shelves do click into place, so you can tell when it is in the right slot and fit into the furnace. And then you'll also have these setters that you'll place your part on when you are sintering your part. Next slide. These are just the dimensions of those shelves. So there are 7 total shelves. They're each labeled with a load rating. So there are 6 shelves that have a 5 kilogram max load and one shelf at a 10 kilogram max load. And then you also have the height between them. But like I said, you can choose to take shelves out so you get some taller space for taller parts if you need it. So it's very flexible there. Next slide. So now diving into that software that I mentioned before, so Live Sinter is a really great simulation tool that we have developed to pair with our binder jetting technologies. With any sinter-based technology, you are taking relatively fragile parts when they're in what we refer to as the green state. So this is when they're just being held together by that binder. And then we're heating them up to some very high temperatures. When you do that with such a fragile part, there's going to be a lot of forces acting on that part and forces that are going to want to cause certain deformation. Forces like gravity pulling down on the part or the dragging forces as it's shrinking across the setter, those are all going to play a part in how the part is going to react in the furnace and potentially deform in the furnace. So we've developed this software that's actually going to simulate your part through the entirety of that process and predict those forces and potential deformation. And it's actually going to create a negative offset of that. So we can counteract it before we even start to print our parts. And that's how we're able to get to a final part faster with fewer iterations. So if you go to the next slide, we have a little example of this. So on this side, you do see the little interaction of how the software is processing that part and how it's simulating it through. You'll see the color differences, which shows different areas that are going to be a little bit more prone to certain deformation based off those forces. And then the next slide.
Is that playing? I don't think so.
There we
Is it
go.
playing? Sorry.
No worries. So this is a little comparison. So on the top left, we have a part. If that's the part that you wanted to print, if you were to print that without Live Sinter and without support, you'd likely see when you sinter it, you're going to end up with the result on the bottom left there, where you can see that crossbeam is drooping downwards. Those feet get kind of splayed outwards, and that is because of the gravity pulling down on the crossbeam and the dragging forces of the part shrinking across the setter and the sintering. Obviously, if that part on the top left was what you originally wanted and what you originally designed, that part on the bottom left is probably not going to be satisfactory to you. It might not even fit into the application that you need it to, so it's clearly not the part that you originally wanted. So instead, we actually run it through Live Sinter, and Live Sinter predicts that result on the bottom left. And it's going to create a negative offset geometry to counteract it. So to counteract that crossbeam drooping downwards, it's actually going to change the geometry and pull that crossbeam upwards. And to counteract those feet bowing outward, it's going to actually pull those feet to toe inwards a little bit to counteract that dragging forces there. So when you are sintering the version of the part that you ran through Live Sinter, still without any supports, you're able to sinter it to that bottom right there to the original geometry that you had wanted. So it's a super useful tool that helps us get to the final part faster with fewer iterations. Next slide. One other great benefit of the Live Center software is in addition to the pre-simulation of the entire printing cycle, you can also run scan adjustments within the software as well. So if you run your part through, you decide you want to get a little bit tighter on the tolerances, you can actually scan your part, load it back into your Live Center file, and it's going to compare its original prediction of the deformation and its original negative offset to what actually occurred. And it's going to create a new negative offset based off that to help you get even tighter on your tolerances. And you can run this scan adjustment on both parts that you had previously run through Live Sinter, as well as parts that you maybe chose not to run through Live Sinter and later decided you might need it. So it's a very useful tool that we have. Next slide.
All right.
I think I'm going to hand it off to Axel to go into our studio system.
Thank you very much.
Thank you, Deanna.
All
Right.
right.
Okay, so we'll talk about the studio system. The studio system is the entry-level metal 3D printer that is made by Desktop Metal. It's a very simple process of printing. So you print a green part, as explained earlier by Tiana, and you sinter this part in the furnace. The specialty of the studio printer is that it uses a ceramic interface layer between the metal part and the support. So you can actually just pop the parts right off the support and the raft without actually having to use a wire EDM to cut your parts off the base. Next slide. So here's a list of all the major metals that can be 3D printed with the Studio, primarily stainless steels, tool steels, Inconel, copper, and titanium. The titanium and copper require an extra step of chemical debinding, but other than that, all the other metals are a two-step process where you just 3D print, and then sinter and thermal debind the metals itself, right? Next slide. As you can see, the image on your right is actually a photo of the furnace that is recommended for the studio. It has a very similar rack-based system where you have shelves and you can place multiple parts on these shelves, and you can have multiple configurations depending on the size of the part. It's very easy to take apart and put together. And overall, it reduces the cost by, if you have more parts, it's more cheaper to run because the sintering time will pretty much stay the same depending on the thickness of the part. Right, next slide. So here's a little bit of the specs for the 3D printer itself. So it's a smart system that's controlled by the Desktop Metal software. All your parts, your 3D files have to be loaded into the Live Suite software, and you can use CAD files, step files, SolidWorks files. All native CAD is generally accepted right now, and you can control the settings. And all you have to do is connect your 3D printer to the Wi-Fi or local network, and you can upload the files to it. Um, the process itself is pretty standard, so it works like a regular 3D printer where you have sorry, I'm thinking about what I'm trying to say here. So yeah, it works like a regular 3D printer. It has a 400 micron nozzle, and if you want to have a more fine finish, you can go down to the 250 micromillimeter nozzle. Um, all right, next slide. So here's a little bit more about the furnace. Again, the studio system works with a thermal debind. So a thermal debind is the process where the binder from the material is actually removed inside the furnace. As you can see, the furnace itself is pretty small. It's easy to move around. You can actually fit it through an office door, but it does go up to pretty high temperatures. As you can see, it can reach a peak temperature of 1400 degrees. So it does require a space that allows for adequate venting of the inert gases that are going to be used with it. So the type of gases that you have to use are argon or a hydrogen blend like a forming gas. These have to be acquired from a third party. And all we do is use this gas to hold it in the furnace, and then it's vented out to a small, like a 1/4 inch pipe. It also requires a three-phase electric connection, so that would be something that you'd have to look into. All right, next slide. So a few of the applications for the studio, impellers, wall components, housings, fixtures, prototyping, that would be the most used application for the studio. So you have an idea, you quickly draw it in CAD, 3D print it, test it out, and iterate again and again. That's the freedom of design that the studio printer really gives you. And that's where it would be recommended to be used the most. All right, next slide. So yeah, now we'll talk a bit about the shop system. The shop system is more designed for machine shops. It does use the same furnace as the studio. As you can see on your right, that's the furnace, and on your left is actually the shop 3D printer. It's an ideal platform for customers to start off on a studio and then ramp up towards the shop. And as Tiana showed earlier, you could follow the steps and keep ramping up towards production. The shop is definitely a different technology. If you can go to the next slide. The technology used by the shop is called binder jetting. Binder jetting is the process where a liquid binder agent is applied to metal powder. And this agent is applied on a layer by layer process, eventually creating a 3D structure, which is the green part. So binder can be done with metal, sands, and ceramics. So there's a host of materials that you can go with. Some of those materials will be in the next slide. All right, no worries. The shop system specs. So right now, the shop itself comes in three different types of configurations: the 4 liter, the 8 liter, and the 12 liter. There is a larger version, but that's generally not recommended. The layer height is in the range of 50 microns to 100 microns, and the throughput is 800 cc's an hour, which is very fast. So you can actually fill up these builds in a matter of hours instead of say DMLS, where your laser sintering could take days. The resolution of the printheads is 1600 dpi. What that means is you can get very fine detail finishing on your parts right off the machine. So next slide. The type of materials that are available, as I mentioned earlier, so 17.4 pH, 316L, and 304L are the stainless steels. These are the backbone of the shop system. Stainless steels are your way to go for the shop. And also now we can do Inconel 625, 718, and chromium cobalt, which is more for medical applications. Many customers ask us, can we do aluminum? Well, no, but you can definitely do part replacement. So if you had a part that's in aluminum, you could, redesign it for additive and 3D print it in stainless steel, ideally 74 pH, and it would probably work pretty much the same. All right, next slide. Let's talk about a few production scenarios because the binder jetting process is a process where you do not require any base, support in the sense that, you're sintering onto a metal plate or you're 3D printing onto a raft. You can actually 3D print parts, free of support in that sense. You can have different type of scenarios, mix, batch, mid-volume. It's very ideal for mixed volume. So you have high degree of variable designs, whereas using the same, you'll have a good throughput for parts that have the same design, but if you have variable design, that's where you get the max value out of the shop system, right? So next slide. What are the key features? So as I mentioned earlier, very high resolution printing. So 1600 by 1600 DPI can go into ultra fine finish or high tolerance on your parts. You can print up to 70 kgs a day, which would be much faster, almost 10 times faster than laser powder bed fusion. You have a simple post-production process where, all you're doing is taking the parts out, cross-linking them, depowdering them, and then sintering them. So you're not really doing a lot in terms of post-producing or post-production for these parts. And again, you have the advantage of live sinter that Tiana mentioned earlier, where you could 3D print a part, scan it, and improve it over time, as 3D printing is a process of iteration for sure. All right, next slide. So the whole solution, as you can see over here, starts off with the printer. So step one would be 3D printing your part. So you get a box, either 4 liter, 8 liter, 12 liter. You 3D print your parts, and you take them out and move them into the drying oven, which would be all the way on your left. In this oven, a cross-linking cycle goes on where the binder solidifies even more and parts get stronger. After that process is done, you move it into a powder station where you depowder the part and recover all the excess powder that's not attached to your part. So now all of this powder can be recycled. You're not throwing anything away. So unlike laser powder bed fusion, where you're going to have a lot of ash in your parts, you don't really have anything in this powder because there's no thermal process being done at all right now. Once you have your green parts from the powder station, you move them into the furnace and you run it through the sinter cycle. So it's a pretty straightforward process, and it's been really tuned down for high efficiency by Desktop Metal. Right, next slide. Some of the applications for the shop system, of course, high tolerance parts, impellers, couplings, brackets, jewelry, automotive components, anything fist size or smaller is what would really be the a green zone or Goldilocks zone for using the shop system. And next slide. So why adopt the shop? Well, first of all, you can eliminate tooling. So you don't have to worry about molds. You don't have to worry about work holdings. You could 3D print your part, ready to go, right out of the furnace. Take advantage of additive. So you can use topology optimization. You can do lightweighting. You can improve efficiency of your parts. How about printing hard to machine metals? So, sometimes laser powder bed fusion works pretty well for some applications, but in applications where you have a lot of support, binder jetting would be the best way to go because you wouldn't have to machine your parts after 3D printing them. Free up your CNC. That's a great reason. You do not have to touch your CNC. You can use your CNC for production, batch production, and actual parts that are better for CNC and not good for 3D printing. And overall reduce cost, right? So when you talk about cost, 3D printing is definitely cheaper on a part-to-part basis if you look at the overall cost of manufacturing a part. And especially if you have a mid-volume production, like 100 to a few thousand parts, 3D printing would be, binder jetting specifically, would be very difficult to beat in terms of cost. Right. So next slide. All right, I'll give it back to Tiana now.
All righty.
Awesome. So another system that we have is the InnoventX. The InnoventX does also work off of a binder jetting technology similar to the shop, but it goes about it in a slightly different way. So with the InnoventX, we do have a relatively smaller build box. So it is about 65 by 160 by 65 millimeters. This system is really designed for R&D, material development, education sectors, stuff like that. Because of the small print box, it's a bit easier to test the different materials because you don't need quite as much powder to go through those processes. This system is also a bit more flexible in the settings that you're able to change. So whereas the shop system is more of a turnkey system designed to be kind of an intro to binder jetting technology, the InnoventX does have a few more dials if you're looking to get a little more into the R&D, material development, stuff like that. So with our layer thicknesses, it is adjustable between 30 to 200 microns. Our tolerance is about plus or minus 1% or 0.2 millimeters, whichever is larger. It does use what we call triple ACT printing, which I'll get into a little bit more in the next slide. It does print unidirectional, but it is programmable to be bidirectional printing. And we use a piezoelectric print head, which has 256 nozzles and does a multi-pass over the print bed to make sure each layer is properly saturated. There are also three configurations of that printhead for the InnoventX, with the difference being the droplet size of the printhead. So we do have a 10 picoliter, a 30 picoliter, and an 80 picoliter printhead. And whichever one you choose is going to vary dependent on what is most important to you. So obviously the 10 picoliter printhead will be able to get finer feature details and stuff like that, but it is going to take a bit longer to print because you're not printing as much volume at a time. Whereas the 80 picoliter might not be as detailed, but you will be able to print through your parts faster. So it's kind of a balance on what's more important to you. The Innovent system is also open platform for powders. So while you can buy the powder directly through us, it is also open platform if you wanted to develop your own materials as well. However, it is closed for binders. So we do only allow using DM binders, and that's because we don't want you to put anything in the system that could damage it. But we do have 5 different binder types available, each with its own benefits for different properties of your parts. So we have fluid fuse, aqua fuse, clean fuse, phenol fuse, and turbo fuse. And some of them have higher green strength. Some of them are more of a cleaner environment for if you have strong EH&S requirements, stuff like that. So we can help you choose the binder that's going to be best for your applications and your facilities. Next slide. So like I mentioned, we do have the 3 different printhead sides, the 10 picoliter, the 30 picoliter, and the 80 picoliter. This is just a little graphic showing the different resolutions of them, and how to pick which one you might want to use. So it shows you obviously the best for fine features is going to be that 10 picoliters, like I said, but the shortest print time is going to be about 80 picoliters. For drying time, the 10 picoliter is going to have a shorter drying time because it is dropping less volume at each pass. And those are the different resolutions you can get. So you're getting 800 by 800 DPI for the 10 picoliter, 400 by 600 for the 30 picoliter, and 400 by 600 for the 80 picoliter. And then the average layer height does vary. So we typically recommend a 30 micron layer height at the 10 picoliter versus a 100 micron layer height at the 80 picoliter. Next slide. So like I mentioned, the Innovent does also use the binder jetting process. So we are going through these 4 main steps here. The first step being that print step. So that is where we're spreading that loose powder and jetting out a liquid binder agent into that loose powder. And that's how we are forming the parts. So the entire build box is going to be full of metal powder, but it's only going to have that binder where the parts are. Parts straight out of the printer are pretty fragile. It's not something you want to handle, so they actually go into a cross-link step as number 2. This is basically a thermal cure. It is a little oven that heats the parts up just enough to activate that binder and make your parts strong enough to handle. From there, it'll go through a depowder step. So this is where we're removing all that loose powder from the build. So we're left with just our parts that have the binder in them. This is the most manual step of the process, but also the most important. Any powder that you're leaving on your part is going to bond to it in the furnace. So you really want to make sure you're removing all of that. And like Axel said, that depowder station, you are able to reclaim that loose powder that you're removing from the builds to use for future builds as well. From there, it'll go through a sinter step within the furnace. In the sinter step, there are 2 main steps. The first is a thermal debind, and that's where it's going to remove that binder that's holding those metal particles together. And then from there, it's going to heat up to a higher sintering temperature around the melting point of the metal material, and that's when those metal particles are going to start to bond together. They do end up filling in the voids left behind by where that binder was removed from, so we do get about a 20% shrinkage, but that's all. You can compensate for that when you're slicing your parts. After that, you do have a fully metal part that you can post-process any way you would typically post-process a metal part. You can do any quality assurance on it as well. One other thing I will note, if your part does require any supports, we do paint on what's called an anti-sintering agent between the depowder and sintering steps, and that's going to act as a barrier between your part from the supports, and that's what makes it so that we're able to hand remove our part from the supports. No need for any machining or anything like that, just like Axel said. So we are able to remove those by hand, which makes it a lot easier for post-processing. Next slide. So getting into that triple ACT, so this stands for Triple Advanced Compaction Technology, and this is basically the technology that we are using on our X series systems to dispense that metal powder. So this is our patented system for dispensing, spreading, and compacting the fine powders that we use on the X series systems that allows us to get our high green strength. So we do have an ultrasonic dispensing system that's going to help us get a consistent flow of those fine powders. So it is going to ultrasonically shake those parts to dispense it onto the print bed. And then we have two separate rollers. We have a spreader roller as well as a counter rolling compactor, and that's how we get that high green strength. So this complete system works together to give us a green part density with a standard deviation of less than 1%. Um, and those ultrasonics and independent roller speeds are adjustable, which helps us be more flexible for material development of other materials as well. Next slide.
All right. Thank you both. That was excellent. So just to kind of wrap up, we talked about the Pure Sinter furnace. It's a new vacuum furnace, and something new means new technology. Um, it does solve some traditional vacuum furnace challenges. It is affordable and as mentioned, innovative technology. It's state of the art. It has low acquisition and operating costs with high efficiency, and it's utilizing a pretty simple to learn and use simple sintering software. Works with multiple products across the Desktop Metal line. Talked a little bit about the studio system. This works with multiple materials, including some steels, stainless, copper, Inconel, titanium. Um, really good for batch processing and fast part printing. It does have a software controlled workflow. Um, it is scalable with your production needs. And then the shop system, really designed for machine shops. It's proven binder jetting technology, flexible production scenarios, as you saw the three that were spoken about earlier. And then we have the InnoventX. It's available in three drop volume configurations. It's a simple process of print, cross-link, depowder, and sinter. It is a very shop-friendly format. Most of our audience is, they're traditional subtractive machinists, so you can certainly use these as a complement. Um, and as Tiana mentioned, we're really looking at education, some R&D, and material development here. We do have a studio system in our Anaheim office. You can come and take a look at it. If you're interested in that machine, we can print you a test part. We could even arrange for, probably a test part for any of the other machines that you might be interested in. We are not a 3D print house, though. We're here to just kind of prove your part out. We find that many companies outsource their 3D printing, and that's totally fine. But it does take a little bit out of your control. It adds time to the process, even if you're just talking about shipping back and forth, but working with the company to make sure they're putting out what you need. Um, and then if you get into the habit of doing that, I love this quote. If you need a machine and don't buy it, then you'll ultimately find you have paid for it and don't have it. So you're ultimately going to end up spending more money in the long run than purchasing a machine yourself. To close out, you can find us at CAD-CAM.com. Sign up for our newsletter. That's my marketing plug. And that did not change, so I apologize for that. But you can find Desktop Metal at desktopmetal.com. Yeah, reach out to us at marketing@cad-cam.com for a demo. Talk to Axel. He'll be your main point of contact. Or you can head up to our Desktop Metal page on our site, which is found under Products, Additive, Desktop Metal. Um, both of our companies are all over social media, all the major platforms you can think about. So search, follow. like, repost, all that fun stuff. Um, we're going to take this recording and throw it up on our YouTube page as well. We introduced CAD-CAM TV about 2 months ago, and this is a specific channel on our YouTube page. So this is where all the products that we represent, we're coming out with little tips and tricks videos every single week to help you with the products that you're using. It's coming from the experts, mostly our trainers and our tech people. So check those out. We just released one with Axel about a week ago for Desktop Metal. Um, and like I said, these are, short, easy to consume weekly releases. We also are housing all of our webinars. In the past, we've done 3 more before this. We plan to do plenty more and anything in the future. Speaking of the next one, we do have another line of 3D printers that we're going to be talking about next month. It's called Robos, and those are really super polymers and things like that. So carbon infused polymers. That'll be on March 11th, 1 month from today at 9 o'clock in the morning Pacific. As soon as this recording is available, we'll be sending out that along with the invites. So everything we're doing here is really to show that closed loop manufacturing concept. And then, of course, if you have any other questions, feel free to reach out directly to any or all of us. We're here to help you out if you're interested in what we showed today. Um, that pretty much wraps it up. We'll get you out of here a little early. If we see any questions in the chat, we'll hang out for a few minutes. But other than that, just want to thank you for coming, and we'll hopefully see you at the next one. Tiana and Axel, you guys were excellent, and I thank you very much for your help.
Yeah, thank you.